So we're looking at this CloudFront service, and what we know about it is that it's a content delivery network, which is a network of servers scattered around the globe, and those servers essentially are caches. They cache content, and content we said could be anything, whatever you want to make available to your user base. In our case, the content is going to be a React app, a static version of a React app, which means it's a bunch of, well, it's one HTML file, a JavaScript, some CSS, maybe some images. That's what constitutes the content in this case. And so from a CDK point of view, what you've got in order to sort of create your uh, your CDN specifically for your content. What you've got to do in your CDK stack is indicate where is the actual source of your network, which we call the origin. In our case, it's going to be an S3 bucket, but it could be any type of HTTP compliant uh, uh, kind of backend, I suppose, if you like. And the second thing then is you have to declare the what's called the distribution in your CDK stack, and the distribution kind of describes how your content delivery network is going to be managed. Yeah. So we had got to the stage really, let's skip over these, where we said, look, this is our objective. We want to provision a CloudFront distribution for a single, simple React app. Okay. Using S3. Oh yeah, using S3 as an S3 bucket as the origin. So let's look at the CDK stack to achieve that. Now I've expanded it a little bit, so I'm actually going to deploy a CDK stack that will consist of our CloudFront distribution, but I'm also going to set up a web API. Ultimately, we'd like our React app to be able to communicate with the web API, but initially they will be completely separate from one another, and there won't be any integration between them. And when we do get to the stage where we can integrate them, then essentially we've got what we now refer to as a full stack web app. Okay, so here I'm in the lib folder, and I've got a couple of things going on here now which are new, and they're kind of by the way more so than anything. So I've actually broken my lib folder up into two subfolders called constructs and stacks. So there's a couple of points here now, and we're kind of veering away now from the main topic, which is CloudFront. But up to now, all of our stacks have comprised of, uh, sorry, all of our CDK apps have comprised of one stack, and that's it. But the stack file can get quite long-winded. So there are a couple of things you can do in that case. One thing is you can actually take what I will describe as logical blocks of code out of the stack file and put them into a separate file. Now, that separate file is not a stack file. It's actually a construct. In other words, we can create our own custom L2 constructs, which is something we haven't done up to now. And it's a pretty straightforward thing to do, really. The mechanics of doing it are straightforward. Uh, I was going to say the difficult thing, but it's not really that difficult. But the main step in doing that is identifying what would constitute a logical block of code from the original stack and putting that into a separate construct. Now, in our case, there is a very logical breakdown of the overall uh, kind of infrastructure that we want to provision. And you can see here from the names of the two. So these two files, this one here will contain all of the infrastructure code for creating my web API. And this one here will contain all of the infrastructure code for creating my S3 bucket, making it the origin of my CloudFront distribution, and also declaring the CloudFront distribution itself. Yeah. I've got a separate subfolder called stacks. Now, at the moment, we have only got one stack, but we could actually have, and later on, we will break this up into more than one stack. So if I look in my stack file now at this stage, it's actually quite short. It's the shortest one that we've had so far, really. Because all I'm doing in it is I'm essentially using my two, what I'm calling my custom constructs here. So I'm creating an instance of an L2 construct called this, but this is my L2 construct, because you can see I'm importing it here. Where am I importing it? I'm importing it here from my, and also I'm creating an instance of my front end construct. Okay, so we look at the web API one first, even though it's actually going to be kind of redundant, but here's the web API custom construct. And the first thing we see is that, okay, this is a class, but this time it extends a superclass called construct. It's not extending the stack class. And so it's as simple as that. That's how you create your own custom construct. A construct can have properties, and my one has one. And the properties, they are publicly accessible. They would be related to uh, um, any kind of values or any, what am I going to say, any pieces of infrastructure that you are creating within this construct, and you want to make it available to other constructs. In other words, you're kind of you're exporting it, right? So that's fine, because in our case, our front end custom construct will need to get a reference to the API gateway instance. Essentially, that's what we're storing here. You need to get a reference to the REST API that's being created within this construct. And the rest of it then is, here we go. We're creating a web API. Sorry, we're first of all creating just a Lambda instance. My web API now is just going to consist of one Lambda. And that Lambda doesn't really do anything interesting. And here we go, creating our RESTful web API. And, the rest is fairly standard stuff. Okay, so that's that construct. And the front end custom construct, that's where we have our CloudFront stuff now at this stage. So we'll dwell on this a little bit. Now, again, a general point, when you have your own custom constructs, the constructor for the construct, as we can see here, it has three arguments, just like every L2 construct has three arguments. It has the scope argument, it has the ID argument, and the third argument is what we call the props argument. And for any inbuilt L2 constructs that we've used, and we've used lots of them, we've used Lambda, we've used DynamoDB tables, etc. The third parameter of any L2 construct essentially is the configuration, and it's unique to, and the shape of that configuration object is unique to each type of L2 construct. And the same is the case in our custom construct. It's up to us essentially to define the structure of this third props argument. And that's what I'm doing up here. So I'm defining a custom, I'm using the TypeScript interface type. And in my case, there's really only one part of the configuration of this, which is I want to essentially kind of pass in the URL of the web API that's created in the other construct. Yeah. Okay, so and if I go back and look at my stack file, you can see here now when I'm creating an instance of my front-end construct, the scope is this, as it always is. The identifier is just any string that uniquely identifies this construct within the overall stack. And the third argument is a single property object. And what I'm actually passing in is what was returned by up here. This is a reference, this is a reference to the API construct, and I'm accessing a particular property of that API construct, and I'm actually accessing the API's URL, which is the property of the API construct that I showed you there a moment ago. Okay, so let's go back and look at the front end construct. So here we go. We're creating an S3 bucket because I'm using an S3 bucket as the origin for my distribution, and it's an ordinary. Okay, we haven't used S3 so far, but we know what S3 buckets are. So there is just some configuration of my S3 bucket. In particular, I'm blocking off public access. You might remember when we spoke about it the last day. An S3 bucket that's used as the origin for a CloudFront distribution, you essentially want to prevent anybody trying to access that bucket directly. So that's why we're disabling public access. The removal policy, that simply means, in my case anyway, when I destroy this overall stack, then I want the bucket to be destroyed as well. So that's a bit like our DynamoDB removal policy. And I wouldn't worry about the third one or the last property there. So that's fine. That's just an ordinary S3 bucket. And here now is where we actually create our distribution. So this is yet another L2 construct that's built into the framework. And what do we, there are a number of parts of the configuration that we can do for distribution, and I'm just showing you some of them here. So I'm just telling it, look, what is the name of the what's the name of the file within the, in my case, within the S3 bucket? What's the name of the file that should be served when the user just enters the domain name for the distribution? A distribution now will get a domain name generated for it, a URL in other words. So let's supposing the URL is foo.aws, right? Then if a client just inputs in their browser foo.aws, then what file should we return back to them? Or what piece of content should we return back to them? Because they haven't specified any content. And so in my case, I'm returning back index.html, which that kind of adds up because my bucket is storing a static React app. Minimum protocol, essentially I want my I want any, when a client tries to access or send a request to my distribution, they have to use HTTPS rather than HTTP. Default behavior. This is really where we connect up our distribution to our origin. And you can see that's what I'm essentially doing here. I'm telling it that the origin for this distribution is what is my bucket. And also I'm saying that uh, the, the distribution only has read access to my bucket. In other words, you won't be able to do any HTTP post or put requests. You won't be able to issue those to this particular CloudFront distribution. You'll only be able to do read requests. Yeah, and again, that kind of makes sense because it's storing a static React app. Um, now, of course, when the React app is loaded into the client browser, okay, the React app can send post requests and put requests, but those post and put requests are not going through the CloudFront distribution. They presumably are going directly to the web API that represents the back end to our React app. So the read here only relates to requests from a client directly to our CloudFront distribution network. What else? Yeah, okay, we're telling it to compress if there's any kind of large content that has to be delivered from the origin back right out to the client and use compression on that, which makes sense. And these are the only, okay, that's kind of reinforcing the read really. I'm only allowing get and head and option requests to my CloudFront distribution. And the last thing here is just saying that a client can only make HTTP, well, sorry, what this is saying is that if a client actually tries to make a HTTP request to my CloudFront distribution, and when I say make a request to my CloudFront distribution, we really mean sending requests to one of our edge location servers. But either way, if a client sends a HTTP request to an edge location server, then we are getting that request redirected to HTTPS. And, the edge location servers will take care of that. So that's the configuration. It's kind of a minimal configuration of a CloudFront distribution. But of course, when we CDK deploy this thing now, it's going to create a distribution resource in CloudFront. But the kind of net effect of that is there's going to be some information pushed out to a certain subset anyway of the edge location servers, telling them about this distribution and getting them to enforce some of the restrictions that I'm kind of specifying here that all kind of happens behind the scenes. So that's fine. That's my distribution. And in my case, this is my origin. Although it only becomes an origin as a result of this kind of statement here. Sorry, this statement here. We can ignore that. All I'm doing here, we've seen this before, all I'm doing here is just uploading my static React app up to the S3 bucket. And I'm also kind of tying together the fact that this bucket is the origin for this distribution. And that's okay. This is kind of telling it where in the origin, where should it start storing the content? And I'm essentially saying start storing it from the top level of the bucket itself. And that's it. Now, a distribution is going to be a domain name is going to be generated for it, a URL in other words. And I'm outputting that URL here. And I've done CDK deploy of this stack already. And the URL that it generated for the distribution is here. Okay. This other URL, that's the URL for the web API. Because again, just to remind ourselves, if we go back and look at the stack file, I'm deploying a web API via my custom construct, and I'm also deploying my CloudFront distribution via my front-end construct. So when I do CDK deploy, I get both the URL of my API gateway instance, and I get the URL for my CloudFront distribution. I'm not really interested in the API at this stage. So if I grab the URL of the CloudFront distribution, which is this here, copy that, paste, and that's my React app. So when I hit return, having entered my URL, the request went from my browser here to the edge location server that's geographically closest to me. That edge location server checked in its cache. Does it already have the content? And in my case, the content would be the index.html file that's at the root of this of the origin, the bucket. If it does, then return it back to my browser. If it doesn't, send the request back to S3 and get it to return the index.html. And eventually the index.html reaches my browser. And of course, we know what an index.html for a React app will have. It will have links to a JavaScript file and a CSS. So those requests are then sent by my browser to the edge location servers, and it's the same process. The edge location server checks, does it have the JavaScript and the CSS? If it doesn't, get it from the bucket, cache it locally, and then send it back to the browser. I suppose what I should have looked at, so it's working, looks like, but let's poke around the actual in the AWS cloud itself. So if I go into CloudFront, and select, I don't want to know about that, sorry. You can see I have distributions here on the left, and there's my distribution. No, there's nothing, we can poke around, but we could get probably gives us the domain name. Look, it gives us the domain name, which is the domain name that my stack outputted to the terminal, but I could get it from here as well. And we could look at these stuff down here, but we don't really need to right now. So that seems to be there anyway. If I look at S3, which is my origin, now in my stack, I think I gave a particular name to the S3 bucket just to make it easier for us to identify it. And the bucket is this one. Is that? No, that's not it. Can I pick it out? Oh yeah, it's this one here, right? Let's just go back to the stack to the front end. Yeah, you see here I gave the bucket a particular name. Otherwise, S3 would generate a random name for it, and that would all work fine as well. But and so if I go into that bucket, I have an index.html and I have an assets folder and I have an SVG file. Now that should, and if I go into the assets folder, I have a CSS file, I have a JavaScript file, and a ping and another SVG file. And that correlates exactly with, if I look at my React app, my original React app, and if I look in the dist folder, which contains the static version, my dist folder has an assets subfolder and it has an index.html. And if I look inside the assets folder, it has the CSS file, the JavaScript file, and the SVG file. So that all kind of tallies. Okay, so I deployed my stack. The content of my React app was uploaded to the bucket. CloudFront created a distribution, and look, I've just shown you that it seems to be working, because when I inputted the CloudFront domain name, I did get the content into my browser that I was expecting. So that seems to have worked fine. I know I talked my way through it, but just to be sure, you know, in my browser, I inputted the URL of my distribution. That caused the kind of the internet, let's call it, to eventually route that request to whatever the geographically closest edge location server is to me. I don't know where that is, probably somewhere in the island. It checked in its cache to see, does it have the uh, index.html? If it doesn't, it goes back to the S3 bucket, the origin, and it knows what the origin is, because that was part of my configuration in my stack file. The request goes back to my S3 bucket. The S3 bucket grabs the index.html, which I declared to be the kind of default resource that should be returned if my client doesn't specify a resource. And I didn't in my case. I just put in the URL of the distribution. There wasn't anything after the trading slash, if you like. The index.html was returned here. That was stored in the cache. Then it was given to the browser. And then, the React app started working. And in our case, we know that what happens is, as part of the kind of loading procedure, it requests the index, the .js file and the .css file. And those requests equally went to the edge location server, checking the cache for them. If they're there, return them. If they're not, go back to the origin, requesting them. Same flow happens. Right. Now, the core really function of these edge location servers is they're a caching server really, and we're familiar with caching in general. Caches we know is a kind of high performance. Caches are always key value stores. Uh, the values in our case would be the contents of my index.html or the content of my .js file. Yeah. The keys we'll talk about in a second as to how the keys are constructed. And that's something that you can control from the configuration of your distribution in your stack file. Okay, so these caches live on each CloudFront edge location server. We know that. We know what the the cache keys. The purpose of the cache keys values is to uniquely identify a particular object within my cache. That's okay. That's generic kind of cache related stuff. Clearly, we want to maximize the number of cache hits because really the whole point of using CloudFront at all is to reduce the amount of traffic that's hitting your origin. Um, uh, the last point here I'll talk about a little bit later on. You can invalidate the cache. Certainly when you're sort of testing your CloudFront distribution, every now and again you might want to flush parts of your cache. That flushing is what CloudFront calls invalidation of the cache. What I'm showing you here then, I'll just demonstrate it to you. Essentially what I'm showing you is you can find out whether the edge location server that was used in any particular request, did the edge location server retrieve the content from its cache? In other words, was there a cache hit, or did it actually have to go back to the origin to get the piece of content that the client requested? In other words, was it a cache miss? And if I go back to here and I open up the developer tools, and if I go into the networks tab, let's see. Now I think I'm going to need to do a refresh. So if I do a refresh over here, okay. So here again, we can see kind of confirmation of the various bits of content that were loaded into my browser. So if we just take the JavaScript file, yeah, so I'm selecting that. And if I select headers here, and if we scroll down to, where is it? There should be one there relating to the cache. Oh, sorry, it's the, oh yeah, where am I getting? I should be getting the response headers. I should have checked this before the lecture to make sure I know where things are. There we go there, look. The X cache. So this is a response, a HTTP response header that would have been added on by my edge location server when it was returning to my browser. And you can see over here that it was actually a cache hit. And that was because, I think probably that was because when I did the refresh, because I actually tested this before the lecture, so I would have actually sent a request from this browser to my CloudFront distribution. And so I might have done it maybe 3 or 4 times. And so the edge location server would have copped on to that and realized I need to cache this content because I'm getting a number of requests for it. So it looks like it was a cache hit. Okay, which makes sense. Now I can actually, remember I was saying there that you can invalidate or flush out the cache? And we could actually do that now. And then when I try and load it in my browser, I'm more likely going to get a cache miss. So if I go back to CloudFront, and select my distribution, and down here I can go into the invalidation tab, and I can create an invalidation. Let's see how I do this now. How do I do this? Oh yeah, if I just say I want to invalidate the entire cache, so I'll just say /star. And if I go create the invalidation, so when I click this create invalidation, CloudFront is going to send a request out to the various edge location servers, telling them to flush out the particular part of the cache that relates to my distribution. So we'll do that. Of course, that takes a certain amount of time to work its way through the system, but if I go back now to here and try and delay things a little bit, so hopefully things get actually flushed out. Well, let's just go for it anyway. If I do a refresh here now, I think that worked, and let's check again. Why am I always struggling to find the one that I'm looking for? There we go, and Xcache, and this time it was a miss, because the request that I just sent now, there wasn't any match for it in the cache. And if we refresh a couple of times, eventually the edge location server will cop on and realize I need to cache it. So I've refreshed it a number of times here now. Back again. It doesn't really matter which file I pick. And let's check that response header again. Yeah, Xcache, and this time it was a hit. So the edge location server is doing what it's supposed to be doing. Okay, so I'm just showing you there in the screenshot how to actually find those response headers. So that one is for a what? That one is for a miss, and this one is for a hit. I mentioned there a while ago about the keys for the entries in your cache. Obviously, choosing those is essential because A, they must be unique. But because of the nature of what our cache is storing, what would make a good key, and this is something that you configure in your CloudFront distribution in your CDK's code. And if you don't configure it, then it follows a default pattern. Now, the default pattern in our case is it takes the combination of the host name and what I'm calling the resource part. So the host name would essentially be the URL of my CloudFront, my particular CloudFront distribution. In other words, this part up here, that's the full URL. And if there was a slash something at the end of it, then what follows this slash is what we call the resource path. And that would also be used in conjunction with the host name. That would form the cache key value. Yeah, the cache key itself. That's the way it works. So if we could, which we can't, if we could look inside our CloudFront edge location servers and look in the actual cache themselves, look inside the cache, we would find entries that follow that pattern, where the key would follow that pattern. And there's an example of it there. When the content is a website, which essentially our static React app is, then sometimes what's returned back to your client browser can change depending on whether the original request that came from the browser, let's say it was from a mobile device versus a desktop device. So the actual content that's actually sent back to the browser might vary uh, depending on that, and maybe depending on some other characteristics as well. So what type of device made the request, the language that the device is configured in. Mine is configured in English, but if I had a different language, maybe I'd like the content that's returned back to me to change. Now, of course, that's assuming that my React app can actually deal with those kind of variations. And maybe the location that I'm in might, so all of these things might influence the content that's delivered back to your client. Now, these characteristics in HTTP land anyway, they are specified as query string parameters and or HTTP request header values. So what CloudFront can do is it will actually allow you to use both HTTP header values and query string values as part of your cache key. So not only is the host name and the resource path, but other header values, request header values and query string values, and indeed cookie values, all of them can be used to form the full key for a cache entry. And you can completely control that, and you control it by means of what's called the cache policy, which again is something that's part of the configuration of your CloudFront distribution. We didn't do it in our case. We assumed the default, which meant it just fell back to hostname and resource path string. So there are these policies, caching policies. In fact, there are two caching policies. One is just called cache policy, which is used to control the structure of your cache keys. And so I'm just listing here the different kind of configuration settings that are available to you, as I've been talking about. Also, you can control how long an item should remain in your cache, called the TTL, the time to live. All of that is kind of configurable, and you do it inside in what's called the cache policy of your CloudFront distribution. There's a second policy called the origin request policy. What that relates to is when your client sends a request to your edge location server, and that request contains lots of potentially HTTP headers and query string parameters, and ignoring the ones now that relate to the cache key construction, there may be other query string parameters and headers and cookies indeed in the request from your client. Now, should those other parameters of the request, should they be sent by the edge location server back to your origin if there's a cache miss? Well, you can control which ones are and which ones are omitted by means of this origin request policy. And again, you've got a lot of control over it. You can specify which particular HTTP request headers should essentially be forwarded on to the to your S3 origin, what cookies should be sent back to the origin, what query string parameters should be sent back to the origin. And this is kind of a nice visual of what we've been saying here. So if this was your original request up here with some headers and cookies and query string parameters, then the cache policy That one is the one that controls the structure of the keys in your cache, and the origin request policy, that's the one that controls what is sent by the edge location server back to the origin uh, if there's a cache miss. So it's nice to know about all of these things, but we're not necessarily going to get stuck into configuring these down at a kind of a low level. But it's good to be aware of how much control you have over the behavior of your edge location servers. Moving on in terms of demo, so we deployed a stack there that consisted of a CloudFront distribution, which manages the distribution of a React app. And we also had a web API backend. Now, in the real world, presumably we want our React app to be able to communicate with the web API. But how does it find out the URL of the web API? Well, one way is we could hard code it into the React app. We could deploy the web API first, get the URL of the gateway instance, and just hard code that in our React app. Not a great solution. We'd like to be able to automate it. So how would we automate it in our CDK environment? So that's what I want to look at next, if I have time. No, we're tight on time, as usual. Let's try and get this done though today if I can. So actually there isn't a whole lot extra that we need to do. So if I go back to my stack and go into the front end. So I'm passing into my front end custom construct here. I'm passing in the URL of the web API. Remember when we looked at the stack file? This is a reference to the URL of the web API that's created inside this custom construct, and I'm passing that in here. Okay, so I have access to the URL in my front end custom construct. And there are a number of ways you can approach this now, but one that I came across in an article that I was reading did the following, right? It actually, what I'm doing here is I'm just creating an object. Okay, this is not kind of a CDK code now. I'm just creating an ordinary object with one key in it called API URL. You can call it anything you want to. And the value is the actual URL of my web API. So that's an ordinary object. But what I'm doing actually is I'm going to upload that object into the same bucket that contains my static version of my React app. You can upload as many things as you want to. So not only am I uploading the dist folder, I'm actually uploading the object that I've created here. So if I run CDK deploy now again, because, well, for now anyway, I'll just CDK deploy that. Hopefully it doesn't take too long. And then we look inside the bucket and essentially we'll see this object. And because that object is inside in the same bucket that my React app is in, then I can actually have a fetch call within my React code to fetch this object, which is in the same bucket that the React app came from, and the React app will have access to that bucket. But first of all, I need to let this deploy. It doesn't take too long. While it's working its way there, I'm just going to flip over to S3. Don't think it has deployed yet, but that's okay. Okay, it has deployed, so it should be there now at this stage. Do a refresh. See here, config.json. If I go in there, can I open it? Open it. And it's an object with the key that and the value that. And that is the actual URL from my web API. And we could prove that if we went into the API Gateway service, found the web API, and we'd find the URL of that web API. So that's only part of the story though. So I have this object now in the same bucket as the React app itself. What I would need to do is I do need to make some changes to my React app, obviously. Let's see. Oh, so just by the way now, before I move away from it, I'm not going to have time to complete this now, obviously, but where did I do it? Oh yeah, like you can have as many, you can see this here is an array, right? You can have as many entries in the array as you want to. And each entry is going to have um, kind of the name of an object and the value of that object. The name, in the case of my React app, the name and values are really dictated by the contents of this folder. In the case of here, I'm telling it to, what am I telling it? I'm telling it to give the name of the object that, and the value then is, this actual object itself, contents of this object itself. But that's one part of the jigsaw. The other part of the jigsaw is if I go back to my React app, and really I would have done this first rather than doing the deploy that I did there. But if I go back to my React app and go into, in my case anyway, go into, am I in the right place? I have a use effect hook here, which is essentially trying to make a call to the backend to my web API. So I've got just a local method here, or local function called get backend endpoint, yeah, which is just a function that I've defined in a separate file called config. What did I call it? From backend in the API folder. Where's my API folder? I need to collapse that. Here's my API folder. Here's my backend. Okay, this is written in TypeScript, but that doesn't matter. I mean, you can just do the same in JavaScript. So I need to make some changes here. Now I'm kind of run out of time as usual, but I'll pick the story up with you on this next Tuesday. Now you will need, I will provide all of this code because you will potentially need it for the assignment, but you don't need to wait until I give you this code to start the assignment. You can start it straight away because you can develop your web API. Um, so that doesn't need to, you don't need to wait for me to complete this part of um, the module. Okay, I've gone on a little bit too far. So I'll pick up the story next Tuesday with you. And also, there'll be one final part of the jigsaw, which is rather than having, a domain name that looks like this, which is completely unintelligible, it would be nice if we could have our own custom domain name, which had a meaningful, which was more meaningful in the context of whatever the application is. And I'll show you how to do that as well next week. All right, as usual, I'll turn up at the labs tomorrow if anybody wants to meet me face to face and has some questions about either the labs or the assignment. That's all for now. Talk to you whenever. Thanks. Bye-bye.